All right, in this video, we're going to talk about simplifying square roots. We do usually a good bit of simplification of radicals, square roots, and cube roots, and fourth roots in Algebra 2. Because of the way things ended last year, we did not have the opportunity to do that. We just did a little bit. So I want to go back and review that a little bit with you before we move on into some higher level things. I think we should go back and talk about this just a little bit again. Okay, so in order for you to understand square roots, you first need to understand squares because square root is the opposite of square. So those two things go together. They undo one another. So 5 squared, think back to when you first learned about exponents. 5 squared means 5 times 5. Notice that I have two 5s right here, and I have 25. So if I want to unsquare 25, I want to figure out what I had before, I have to notice that 25 can be broken down into two 5s. Square root is the opposite of square, so there needs to be 2. So the answer to that is 5. All right, let's do this one. Negative 4y squared. Well, that means negative 4y times negative 4y. Negative 4 times negative 4 is positive 16. Y times y is y squared. Now, it's really important to notice here that that squared only goes with the y. It doesn't affect the 16. The square over here, that goes with the y and the negative 4 because of the parentheses. But the one over here just goes with the y. Sometimes people get confused about that. So we don't want to look at squaring 16 again. That squared only goes along with the y. Okay, so let's look at doing some unsquaring. Let's look at some square roots. So in order to do this, I have to figure out what I had 2 of. So I'm going to look at a factor tree. And when I factor, I want to go all the way down to the prime numbers. Remember, prime numbers are numbers that are only divisible by 1 and themselves. They have no other factors. So 9 is not prime. 9 is divisible by 3, but 5 is prime. I can't factor 5 any further. All right, so I want to look at what I have 2 of. I have 2 3s, so when I'm unsquaring, I always want to focus on what I have 2 of. And in this case, because I have 2 3s, 3 gets to come outside the house, but 5, or 5, he does not have a buddy. He has to stay inside the house because there's only 1. You have to have 2 because it's a square root. You have to have 2 to come outside the house, and there's only 1 5, so he stays inside. Okay, let's look at this one. Now we've introduced some variables along with our numbers, but we're going to do it piece by piece. Let's look at the numbers first. Let's look at 60. All right, I'm going to do a factor tree just like I did before. So I noticed that 60 ends with a 0. That's a good indication that it's divisible by 10. 6 and 10, neither one of those is prime. Let's refactor. 6 can be 2 times 3. Well, 2 is prime, 3 is prime, so we're done with 6. Let's move over here to 10. 10 is 2 times 5. All right, 2 is prime, 5 is prime, so we're done with 10. So there is our prime factorization. Okay, it's important to note that you don't have to start off with 6 and 10. I chose to do that because I noticed the 0 and that gave me a clue to use 10. But what if you chose to use 4 and 15? Well, neither one of those is prime, so let's keep factoring. 4 is 2 times 2. 15 is 3 times 5. So look what we have here. I have 2 2s, 1, 2, and I have 2 2s over here. I have 1 3, 1 3, 1 5, 1 5. So it doesn't matter what you start with. What matters is that at the end, all of the numbers are going to match no matter which way you start. So that gives you a little bit of flexibility. Different people might choose to do these a little bit differently, but you're going to end up in the same place, so that's okay. Okay, I'm going to circle the 2s because that's a pair. All right, and the 2s are going to come outside the house. But 3 and 5, they don't get to come outside. They don't have a buddy. So we're going to multiply those back together. 3 times 5 is 15. And 15 is the number that you're going to see in the house. Okay, so now let's focus on those variables. Let's do x first. All right, think about what x to the fourth means. X to the fourth means multiply x times itself 4 times. And if I'm going to circle all of my pairs, I have a pair here and I have a pair here. So that means I would take an x out for this one and I would take an x out for that one. X times x is x to the second. Well, it turns out there's a little bit of a shortcut for that. Remember we said you always have to have 2 to come outside the house. So if I take that exponent of 4 and I divide by 2, 2 goes into 4 2 times with 0 left over. So this number, the 2 that it went in there, that tells us how many come outside the house. So I'm going to get x to the second outside the house because I would have 2 groups of 2. This number down here tells us how many are left over to go back inside the house, which in this case is none, so I'm not going to have an x here at all. All right, let's do the same thing with y. So the exponent there is a 3. I'm going to divide that by 2. 2 goes into 3 one time with 1 left over. So this exponent tells me what goes on the outside. So I'm going to have y to the first. You can put that 1 or not put the 1. It doesn't matter. It means the same thing either way. And this tells me what's left over. So I'm going to have y to the first on the inside as well. So that's going to work out to be my final answer, 2x squared y times the square root of 15y. All right, let's try this one. See if we can factor 80 down into its primes. Okay, again, it doesn't matter what you start with. I'm going to choose 8 and 10. All right, 8's not prime, so let's keep going. 8 is 2 times 4. 2's prime, we're done with that one, but 4 is not prime. Let's do that one again, 2 times 2. And 10 up here, 10 is not prime. 10 is 2 times 5. 2 is prime, 5 is prime, so we're done with that one. Okay, now let's circle our pairs. So I've got a 2 right here. I've got a 2 right here. All right, that means outside the house, 2 times 2 is 4. And inside the house, poor 5, left inside the house again because there's only 1. Okay, now let's look at our variables. So look at that m. You remember that the exponent, when you can't see 1, that exponent is an understood 1. So if I try to divide that, 2 goes into 1 0 times with 1 left over. Basically what happens is 1 is too small. 2 doesn't go into 1. So that means my m to the first just has to stay on the inside. It's too small. All right, let's look at n. The exponent on n is 6. Divide that by 2. 2 goes into 6 3 times. All right, so now remember, this number tells us how many go on the outside. So I'm going to get n to the third on the outside. And this number tells us how many go on the inside, which is none. So I'm not going to have n on the inside at all. All right, now let's look at r. Exponent on r is 8. I'm going to divide by 2. 2 goes into 8 4 times with 0 left over. All right, the number that tells me how many go outside the house is 4. Let me get y to the fourth. The number that tells me how many go inside the house is that 0, so there are no y's left. Okay, now one thing I forgot to point out on the other one, we need to go back and look at this. Right here in the front, do you guys see a positive or negative sign? Nope, it's just blank. So remember, when it's blank, that's understood positive. So because my question is asking about something positive, my answer has to be something positive as well. Well, 4 is positive, no problems there. But how about n to the third? If n is a positive number, 2 to the third, 2 times 2 times 2 is 8. Well, that's a positive. But what if n is a negative number? Then I've got -2 times -2 times -2, and that's equal to -8. So I have to force that one to be positive because my original thing was positive. So if you remember, we did do a lot of this last year, and I know you've done it in the past as well. What forces something to be positive is absolute value bars. So you actually technically need an absolute value on that. I cannot remember if Delta Math requires you to put that absolute value bar or not, but I do know that technically those are supposed to be there. Now, y to the fourth, that one's automatically going to be positive because anytime you have an even exponent, it works out to be positive. It's only the odd exponents that you need to be careful with to force them to be in absolute value bars and force them to be positive. Okay, so let's go back and look at this one. Which one of these on the outside, which one of these do I need absolute value bars on? Do I need absolute value bars on the 2? Do I need absolute value bars on the x squared? Or do I need absolute value bars on the y to the first? Okay, if you thought of y to the first, you are correct because 1 is an odd number. So I should have put absolute value bars on that y to the first. All right, let's do one more. Okay, 5p to the 7th, q to the 4th. All right, let's look at that 5. Well, 5 is already prime. No factor tree, nothing to do there. But unfortunately, my goodness, poor 5. He keeps getting left in the house. There he is in the house. Okay, so now let's try to handle that variable of p. All right, let's see. 2 goes into 7 3 times with 1 left over. All right, so now if you remember, this one tells us how many come on the outside. So I'm going to end up with p to the third on the outside. And this one tells us how many go on the inside. So I'm going to have p to the first, or just plain p, on the inside. Okay, now let's do q. 2 goes into 4 2 times with none left over. All right, so that tells me I'm going to have q to the second on the outside, because remember the number on top tells me how many go on the outside. This number tells me how many go on the inside, which in this case is none. And we do need absolute value bars on there. We need absolute value bars on the p to the third.